And we'll see some real action today. And I will ask you to actually contribute and write code in the presentation. So it will be kind of an interactive one. So if you have your computers with you, please raise your hands if you have preferably MacBooks, and if you have Node.js installed, and if you want to code with me today for microservices. That's great. Yeah, I have a couple of hands. Don't worry, it's super easy. It's actually one line of code that we will write. What? No, I'm not kidding. That's right. It's actually one line of code. And we'll do some, hopefully, fun, interesting demo together. And before we begin, if you have your computers with you and if you want to attend the live demo, if you want to participate in it, I would kindly ask you to create a new empty Node.js project and just do npm install code. I hope the Wi-Fi network will allow us to do it like 50 machines at a time, but yeah. And don't worry about it. It can take some time if the network is slow, but we will still have something like 20 minutes before we get to live coding. So if you want to participate, raise again your hands so that I see the audience. Cool. Yes, this will be amazing. Just do npm install code and wait for me. I want to start with a pun. I want to talk about the elephant in the room. Not this one, obviously, but the big elephant in our room is microservices. And today we're going to talk about what microservices are not, and then we're going to talk about what microservices are or should be, and we'll demonstrate that with some examples. So, who am I? I'm Arman Amcalar. I'm traveling from Berlin. I work for UNU GmbH, which is a mobility solutions startup. We are creating solutions for the future of urban mobility, and I'm the head of software engineering there. We're building really cool, interesting stuff with cloud architectures, with mobile apps and everything. I also lead a software craftsmanship school for women called Lonja Works, and I'm the founder and the lead instructor there. And I usually do teaching both for my private students and then for the common good and the community. I'm pretty active on GitHub. I have a lot of libraries or open source projects that you can see, and the link of the presentation is at the end. I have a front-end library called Erste, which is the first library that I wrote in Germany after I moved to Germany with my pathetic German. But yeah, any front-end developers here? Cool. Check it out. It's the fastest framework for developing mobile applications, hybrid mobile applications. But today we're going to talk about microservices. And as I said, we'll do a quick overview of what microservices are and what they are not. And I'm going to give an example e-commerce application, which I believe is the widest used way of developing software. Like any e-commerce developers here, did you ever write e-commerce code in your life? Don't be ashamed. I already did a few myself. Okay, but yeah, most of the people didn't touch e-commerce applications. You are very, very lucky. You are the chosen ones. But yeah, it's kind of the enterprise application, so we will kind of model the approach over an e-commerce application. And then we'll talk about what a modern microservices application should be, the next generation microservices. Raise your hand if you attended this morning's microservices talk. Okay. That's good. So we kind of covered, or I have to thank the speaker, and he covered most of the basics of what microservices are or can be, and how you can kind of implement them with Node.js. And this is a step forward, and will basically bring it to a whole new level. And yeah, I'll also talk a little bit about Docker. All right, let's start with what is not a microservice. The elephant in the room is everybody is talking about microservices. Raise your hands if you are planning to do microservices or if you're already doing microservices. Yeah, it's kind of why you're in the talk, right? It's a huge hype. It's a huge buzzword. And I've been working with microservices for over 4 years now, and I don't like the connotations that come with the term microservices, so I will try to clear them a little bit. Raise your hands if you have more than 10 services in production. More than 10 services. All right, let's tackle and see what those services are. Because the most common thing that I get is we have a queue mechanism, RabbitMQ, ZeroMQ, or I don't know, Kafka. And we have some queue consumers that are connected to that and processing the messages. And this is a microservices application, or this is a microservices architecture, claim people. But it's unfortunately not true. Having queues doesn't make it a microservices architecture. Even if you have 50 different consumers that do different work, like logging or notifications or reconciliation with payment providers, etc., it doesn't matter. It's unfortunately not a microservices application. Another thing is, they say, oh, but they kind of communicate over HTTP. We have a REST API and some software that talks to each other. And that is unfortunately still not the right definition of microservices. It doesn't mean that it's a microservices application if you have several standalone applications that communicate over HTTP. And this is kind of what the industry is trying to push on developers, because the queue solutions, Redis or Nginx, for example, market itself as the microservices solution. It's not. It's a web server, and it's designed to serve web APIs and stuff, and that has nothing to do with microservices. So they are trying to rebrand themselves, like every other major software out there is trying to rebrand itself as microservices solution, but unfortunately it's not. So what is a microservice then? Enough ranting, right? So there's a single definition, the baseline. If you're breaking down the fulfillment of a client request into multiple programs that run in their own memory space, and if they collaborate on the answer in preparing the answer, then you can call it a microservices application. And the basic idea is you have a single request, like you click checkout on a web page on an e-commerce application, and they use some money from your credit card, they reduce the inventory, they let the delivery people know that you made an order, and there's an invoice, and then if everything goes right, you get a response with the response code 200, right? That's a single response, that's a single click. Now, if it happens in, 5, 10, or 15 different services, then you can call it, yes, a truly microservices architecture, which is something completely different from service-oriented architecture. Raise your hand if you're familiar with service-oriented architectures from early 2000s. Okay, few people. You are also lucky. It was an enterprise hell to develop software with service-oriented architecture. Okay, so again, raise your hands if you know domain-driven design. Don't be shy. Raise your hands. Okay, I assume the rest doesn't. So learn it. Domain-driven design is one of the best software architecture practices out there. You can apply it to any framework, any environment, any application. It's a bridge between business and developers, and it makes life a lot easier for developers as well. And apparently it goes really well hand in hand with microservices. It's a great approach to basically doing microservices. So the goal of this talk is not to talk about domain-driven design, but if you're applying the best practices of domain-driven design, it's extremely easy to break your monolith into microservices. And again, each bounded context in the domain-driven design architecture you have should be one microservice at least. But if you adopt microservices, you have to adopt change. Everything will change, from code, from deployment, from your continuous delivery pipelines, to how you develop software, because some teams will want to write that microservice in a different language. And it means you have to give out autonomy to people. so that's why it's a different approach. And it's not only about software. It's not only about the code you write. It's not only about the environment, whether you're running in Docker or not. It doesn't matter. You can do microservices anywhere, anyhow, because it's an approach. And it implies a lot. It comes with DevOps and automated DevOps, basically. And testing is really important because you have 50 or 100 different moving parts that you have to manage, that you have to make sure still work coherently. And there's another keyword that I want to talk about, maybe not too much, but it's favoring cattle over pets. Did you hear that before? Yeah, raise your hands if you heard favoring cattle over pets. Yeah. So it's like your pets are special, right? They're like children. You give them names, you care for them, you feed them daily, you kind of maintain them. This is how we managed servers up until now. We SSH'd into the servers manually, wrote code, changed maybe even production code on the server, and maintained it, upgraded manually, and they had names, and your infrastructure guys have funny names for each server based on a movie character or the moons of Jupiter or something. But those days are over. Basically, right now, what you want to have is a cattle of servers, which is like, a farm. You have 1,000 sheep or 1,000 cows that you get milk from, and you're mostly interested in the amount of milk you get, and you don't really care that much if one of them dies. You just replace them because you need the production. So obviously, it's not that good of an allegory, but the idea is basically your servers should not know who you are. You should not know your servers by name. You shouldn't be logging into them. You shouldn't be managing them by hand. Everything has to be automated. That's why we call it a kettle. And that is, again, one of the biggest changes that you have to embrace if you want to embrace microservices. So here's an example e-commerce application. It is funnily very much like the graph we had in the morning. So you have some admin interface, an end user interface on the front end, like a web browser, and then you have an API gateway in the middle, which can be Nginx. It works perfectly with or alongside microservices. And then behind that, you have your own set of services. So this is a really simple app. We have a purchase service, a user service, a product service, and a payment service. If you notice, all of them have their own databases. It's a must in microservices. You shouldn't be sharing any code. You shouldn't be sharing any databases. And all your services should be independent of each other. That's why they all have their own databases. But then there are some connections. For example, you can directly talk to the user service to create a user or get its details. And then the purchase service, when you want to make a purchase, you give it a user ID, and the purchase service goes to the user service and takes that user detail from the user service and not from the user's database. That's a change. And I want to talk about the best practices of microservices. So the first one is auto-discovery. Let's say you have a new kid on the block. You have a new service, like a log service, that comes online, or anything else, basically. All your services should automatically discover that without any configuration at all. So beforehand, you maybe did a lot of configuration in your applications, like setting up IP addresses, ports, etc. It doesn't work anymore because you don't even know how many servers you have. You don't even know which applications are on which servers. So there has to be an auto-discovery mechanism to make sure that the purchase service is aware that there's a new service that it can communicate to and align itself accordingly. And we call this alignment zero or configuration. So beforehand, again, we did manual configuration, right? We had, in our CI/CD pipelines, we had a huge file of IP addresses of our servers that we want to deploy, and we managed them manually. Like, these are the IP addresses in my private network that I will be deploying my app. And it was a hassle when you wanted to replace them or scale up or down. You had to change a lot of stuff. Now, again, all of these things are actually automated. So you have another mechanism to do the configurations for you. Maybe 10 of the same application will be deployed on a single server. You cannot listen to port 3000 anymore. There has to be another mechanism to make sure that it's 3001, 3002, 3003, and so on. And all the other services in your application actually know this. So this is called automatic configuration, or if you can manage it, it's called zero configuration. So that you basically do nothing. You just say, hey, here is my app, just deploy it to somewhere, to some machines. I want 10 machines on AWS, 15 machines on DigitalOcean, and this is the application. Just do whatever you want. So microservices have to be highly redundant. If you notice now, there are multiple copies of each service here, because most of them will crash. Most of them will just fail, and you don't want any downtime on your website. So you have to have high availability, and the best way to do it is just to scale out to multiple machines. Since you have zero configuration, you can easily scale out to any number of machines. Because you don't manually configure anything there. Another property of true microservices architecture is fault tolerance. Now, see here, we have the payment service, which just went down. It had 3 copies, but none of them are available right now, okay? This happens a lot when your payment provider is down, or the data center that your payment service is deployed in, it just caught fire. It happens actually, and somewhat frequently with AWS. So what will your application do? Will it really survive? Yes, you cannot access the payment service. You may not be able to get the payment details. But will the people be able to browse the catalog, the product offerings that you have? Because the product service is just fine. And the user service is just fine. Can they see their user details? This is fault tolerance. And microservices should be fault tolerant. Even if a service is down, you should cut the requests that are going to that service, which is called the circuit breaker pattern, and the rest of the services should just work fine. If this were a monolith, you know what happens. There is a problem with your payment provider. It takes like 30 seconds to validate each payment, and there are 1,000 requests piling up for the payment provider, and you're out of your threads on your servers, so people cannot even browse your main page, right? Raise your hand if you ever come across such a scenario. Yeah, great. This is the audience. I like it. But yeah, that is the idea of microservices. This is not allowed. And everything we're doing, we are compromising a lot on maintainability actually, but everything we're doing to alleviate the situation so that our website is up no matter what. Even if there are problems with individual services, it doesn't matter. And obviously, one last property is self-healing. Now, the payment service just crashed, right? You cannot access it anymore. But what you have to do is the orchestrator software, which is maintaining the servers for you, should be aware of this and should automatically scale up more payment services. And since you have auto-discovery, see how the stones are getting into place. When you have auto-discovery, you just spin up new machines and the rest of the system just works without redeploying your code. That is the most important thing. Like, every other service is just working. You're doing nothing to make sure that there is a new set of payment services, basically. Even if it's on a different data center, even if it's on a different cloud provider, it doesn't matter. Or, again, it shouldn't matter. So these are basically the properties of a microservice. So now let's go over an example in Node.js. And it's something different than what was presented in the morning. So it doesn't use Express directly, but there's another library called Code, which, as a disclaimer, is one of the libraries that I wrote 5 years ago, 4 years ago. Back then it was called distributed applications because we didn't know the term microservices. But then we discovered that, well, actually it's what microservices are. And, well, it's basically a library that takes care of all the properties that I've just described. It's, and I will go into details, but it's basically zero configuration. And this is the whole set of code that you have to write to make it work. On the top, you see the service itself. So it's connected to some models, some database models. And it has an API footprint of listing the records, getting a record by ID, and creating records. And on the bottom, you see how you can map it to an HTTP API via Express, which unfortunately requires some configuration because it has to have a port number, etc. But yeah, basically you deploy the two files anywhere in the world, and somewhat magically they work. They find each other, they collaborate, and without you having to do anything else, this thing just works. So what we have here on the bottom, we're just forwarding the requests, for example, the GET requests, to the service on the top. And again, this is the only thing that I'm writing. Okay, so the library is called Code, which some of you hopefully installed. Raise your hands if you were able to npm install Code. Great. Yes, that is good. We'll have some fun. Basically, it's zero dependency. There is no Redis. There is no queue mechanism. There is no Nginx. There is no other software that you have to maintain or run. It's only Node.js. It's only a JavaScript library. There are no IP addresses, no port names, no host names, no port numbers, no routing to manage. It's decentralized. There is no single service that is doing anything by itself. And yeah, it has auto-discovery built in. It's fault-tolerant. It's scalable. It does these automatically for you. And we will demonstrate them in a second. Basically, now is the demo time. Are you ready to code with me? Raise your hand if you're ready to code with me. Yes. Yes, this will be a good presentation. So let's get back to code. Okay. I hope the font is big enough to see from the far back. And it certainly helps me to showcase how simple an API can be. It's like 10 lines of code, basically. And all I'm doing is I'm requiring code here. And I have a database model called contact. It's a Mongoose model, if you know what Mongoose is and how it works. And I'm basically doing the same thing in the presentation. I have a find all API and addition API to add records. This is a contacts app, basically. And another API to read records. And it's just very, very simple. So this is the code that I will be running on my own machine. If you're connected to the Wi-Fi here, I guess the Wi-Fi name is International JS PHP. If you're connected to the Wi-Fi, we should be able to communicate together. My machine will communicate and collaborate with your machines. And I promise you there are no viruses or anything, so it's totally safe. Okay, this is the model. It's very simple. It has a name, address, and a birthday. Very simple contact list. And this is the code that you should be writing. So please type this in your favorite IDE. You just require code, and then create something called a requester. A requester is a special instance of a class called requester, obviously. And its job is to request stuff. Its job is to request information, either as a post request in HTTP terms, although this is not using HTTP, or as a GET request or anything that you can think of. So it's just making some API requests. It can receive answers to those requests and I don't know, log them. That's what we're going to do today. So, okay. Here's the server that I'm running. And I'm going back to the code. Maybe I can even stop this and run it here. Great. I already see some people connecting. And you might be wondering, okay, what am I going to do with this? I just connected, but what? So let's get the list of available users, right? client.send is the API that we're using, and it's only this method that does everything. Find all will give you basically the list of records. Obviously, I made a mistake here. This is an object, and it's supposed to have a type, and it also has a payload, so you can send any information with it. But this returns a promise. Raise your hands if you're familiar with promises. Great. So we just say then console log or catch console log. Okay. So let's make sure this is the API. Yes, find all. And here's the code. So please write it and try it out. I should be seeing your requests here. Yes. I have some requests that are coming in. And hopefully you're also getting a list of people on your own machines, right? Okay. So every time you run it, you'll get the list again. What else can you do? You can actually add people, and I would encourage you to add yourselves. I guess the API is add. Yes. And you should pass in an object called contact, and that should have a name, your name, and location. No, it's address. Munich. This is called Freistadt. Freistadt, Bayern, right? Yes. So please add yourselves, and I will be seeing that. Oh, perfect. Add myself. Thank you. That's very explanatory. And location here. That's fun. Marlon. Zex. Who is Marlon? Hey, hello there. And all right, it's coming in. Hack me. Okay, no, I can't, because it's secure. So if you go back to MongoDB, it's very small, but when I refresh this, I already see the records here. There's an attendee from Japan, Mitsuhide. Hello. All right, so what happens if I just crash the server? Just keep on requesting, either getting or adding records, all right? And I will just restart it. Think that my data center is just down, okay? All right. So here's the first request that came in, and the other ones as well. So basically what happened was your clients were just keeping the requests themselves because there were no servers available. This is another feature of fault tolerance. Basically, even if the payment service is down, we do not lose the requests. We just keep them, store them in memory, of course. And whenever there's a new server available or a service available, we just flush the queue so that you get your response. Okay. Now let's scale this up. All right. I'll go here, Node server, and I will create 2 different servers. Please still make some requests. Yeah, hopefully some will end up here and the other will end up on the top. Yeah, they do. And this is how you achieve scalability, and this can work in any machine. If one of you had the server code, you could run it and we would have more fun. But yeah, this is basically it. This is all the code that you have to write to make this all work. Okay? How does it sound? Sounds magical, right? But yeah, there's no configuration at all. Like, we're just on a public network, and this just works. There's no configuration and nothing. You just did an npm install, write a single line of code, and we could just communicate. This happens between every cloud provider. Like, you can have machines on AWS or Google Cloud, and it will just work. Or your own machines in your own data center, as long as they have an overlay network, which is like the Wi-Fi network we have here. As long as there is a network that connects these two computers, two machines, which is a configuration at the infrastructure level, it will work. And yeah, let's go back to the presentation. Did you like the demo? Perfect. Let's go back to the presentation and talk about Docker, where Docker comes into the picture. So Docker is actually a game changer. And I might be asking too many questions, but it really helps me understand your experiences. So please raise your hands if you have experience with Docker. Whoa, amazing. Perfect. Yes. So basically, Docker gives you, and Docker ecosystem, including Docker Swarm and Docker Cloud, or maybe even Kubernetes, give you out of the box many of these things, like auto discovery, zero configuration, and sometimes maybe some fault tolerance and scaling up and down automatically. These are all supported by Docker. So beforehand, we deployed our code services or microservices manually, and then we had to manage a lot of stuff manually. But Docker came in, and it gave you an immutable environment so that it runs the same on your machine and on your local machine and on your server. So you can set up networks inside Docker environments and containers, and it gives you an overlay network. That is the most important thing. If you're using Docker Swarm, Kubernetes, or Docker Cloud, you can configure an overlay network to connect your containers wherever they are, again, in the world. And since code works with overlay networks, it's a breeze. You just deploy your application, the exact 2 lines anywhere in the world with Docker. And by utilizing its overlay network, it actually saves you from manually creating an overlay network yourself, which is kind of a challenge to make it a secure one. And it also gives you, obviously, auto restart on failure. So whenever your services crash, it just creates a new one, maybe deploying it on a new server, which is, again, a part of fault tolerance, because with code, you saw that I just turned off my server, which is kind of like a crash, and I restarted it, which is kind of what Docker does when there's a failure. And none of you lost any requests, if you noticed that. So that's basically how it works, hand in hand with Docker. And Docker Swarm, and again, Kubernetes and Docker Cloud also give you a lot of stuff out of the box. It gives you orchestration. So you can say, the software that I push, this image should get deployed to this set of servers, and maybe to that set of servers. And this special service, which is like the logging service, should be deployed to all machines out there. And I need partitioning between these groups of machines and these other services. For example, payments should be agnostic of every other service around there. And it gives you scaling capabilities. You can tie it to any monitoring solution, basically, because it works with a webhook, so that you can scale up or down your services depending on your load. It's much like what AWS gives you without the baggage of vendor lock-in. It has rollbacks, so when you deploy something to production, you can easily roll it back without, again, having to do anything and without losing any requests in the meantime. It gives you secrets management via environments, and yeah, it's basically a high availability solution because you can run as many services as you want, and it just keeps track of them, along with their resource management. So you can say, this software should run at most at 100 megabytes RAM, and it will make sure that the daemon or the service just stays at a most of 100 megabytes of RAM. So Docker Cloud is another tool by Docker. It's actually a company called Tutum, and Docker bought the company and made it a Docker native solution. So it's an amazing online service to deploy and manage your whole application, and like from development to testing to automatic deployment and server management. It's an amazing tool, and it comes with a lot of integrations as well out of the box. So you can have your servers anywhere or get notified of everything on Slack whenever there's a new version. It gives you security scans so that, you know, when there's a vulnerability in one of your microservices, you get an automatic message saying, hey, you know, fix this, deploy a new version because there's a security leak. So it's an amazing opportunity. It kind of works with Docker Compose syntax. Raise your hands if you're familiar with Docker Compose. Okay, yeah, that's good. So it has a very, very similar syntax, but you know, maybe 10 or 15% is different. It also gives you terminal access. So I told you that you shouldn't be accessing your servers. That's true. But maybe some of the time, especially when you're trying to debug something, you may want to access your individual containers. And it gives you terminal access, SSH access into individual containers, which is, you know, a huge opportunity from the web interface. It also has a CLI, so you can version control everything, every change, and it's a live running ecosystem. Yeah, it's very effective. So there's another demo of this e-commerce platform that hopefully we will again do together. There are 3 endpoints that you may go into. One is the admin interface, the other is the end user interface, and the third one is the monitoring interface for code. On, you know, we see how the services are deployed and how they interact with each other. All the source code for the e-commerce application, Docker Cloud configuration, and everything is available online on GitHub. This is obviously 100% open source and maintained by an active team. So just feel free to contribute. But let's go. So this is the admin interface. On the left and on the right, you see the end user interface. It's like an e-commerce shop. So there are some products. You can add new products. You can buy some stuff. I see somebody is trying to finish the second item in the stock. And it's a live updating mechanism that you know, you see the changes live. And actually, these are single page applications. Yeah, please go ahead and take the last 2 of the first product. Yeah. Okay. Sorry, I needed to refresh my. Yeah. Cool. So there is a very expensive product that none of us can afford, and like my admin interface is also updating in real time. This doesn't use Meteor or Firebase or anything. It's just code and code only. So code has a front-end component as well. We call it sockend because it's a WebSocket interface. So it gives you real-time updates or query capabilities to your backend services. And, well, thank you. Like $1 trillion. For vegetables, no. I deny that. But, yeah. Users are live, there's a huge list, and you can see the purchases as well, who's buying what. Please don't delete all the database, thank you. Thank you. Yeah. But yeah, so let's see the code in the developer tools, okay? Because it's a single page app, it's a single HTML file that does everything. So this is an Angular application, the front end. And code gives you a standard Socket.io interface. So you just use I/O, which is the regular socket I/O, and you connect to some namespaces. These are maybe the domains or bounded contexts in domain-driven design, like product, purchase, or user. There are different services that we had in the backend. And yeah, on every refresh, we create a new user, obviously, since this is a demo. What we do is we just use emit from socket.io, and we give it the type, create, and as a result, we get the new user, and that's what our user is. And you get the list of products. That's fine. And the interesting bit is here. You have the product service, and you can listen to updates that are coming in from the product service, so that in real time you can update this list of products here. And again, you don't do anything. No configuration, no backend services. You just say product service on update, and you get the updated list, basically. And this is everything there is to a socket.io interface. And obviously, it also works with a REST interface. So here you see we're making use of the HTTP module in Angular to get the list of users, or get the list of purchases. Raise your hands if you're familiar with the HTTP service in Angular. Cool, that's perfect. So it's basically an HTTP interface. And again, we have live update mechanism through socket.io again. But you can mix and match REST and WebSockets and get real-time features without any special framework or anything. You don't have to think about scalability. You just deploy your services independently, and they all work in collaboration, basically. Okay. We have a couple of more minutes, so I wanted to go to the GitHub project. If you're interested, are you interested in this workshop, in this e-commerce application? That's great, thank you. So let's see how we do the REST interface. I already showed you the index.html. Right, it's doing some REST requests to the backend, and then we have socket.io for live updates for the users and for the purchases. As simple as that. And what happens on the backend will take your breath away. No, it's not. It's just a clickbait title. But yeah, we're just requiring code, and it's an Express application. Maybe you saw it in the morning. Express is used for web backends, basically backend APIs. And if you're requesting product over HTTP, over REST API, we're just, again, forwarding it to a product requester. Okay? This is the admin part of my web page. I have a product requester that fetches the list of products for me from the cloud. This is the true meaning of the cloud. You don't even know where your services are. There's no configuration again. And we're just sending it out, hoping that somebody eventually will respond to our request. There is a timeout. Obviously, you can put it in a timeout. You don't have to wait forever. But when there's an answer, you can just send it back to the HTTP interface, to Express, and through the client to the web browser. And this is how it works. So this is a REST API over code, so you don't have to use the WebSockets API. And here's the definition of the product requester. There's a special field here called namespace, and this is doing the WebSockets magic. When you put a namespace in a request or a responder, it shows you that it's connected over WebSockets to the client, to the end user, so that you can send some messages out to your users. And yeah, as I told you, Express has to listen to a single port, otherwise it will fail. You can use automated port finding, but in the end, it's configuration. But that's not related to code. Code obviously works without Express. So this is the admin. Let's see what the services are doing. Like the user service. Again, it's something very similar that we all did together. There's a responder in the service side, and there's something called a publisher. That's what does the auto update and real-time synchronization features. It basically publishes changes to the world, if we want it, obviously. So the same thing that I'm doing. This time I'm using callbacks instead of promises. So there are callbacks if you somehow for a reason don't like promises, you can use callbacks as well. And all I'm doing is I'm just forwarding it to Mongoose. And no, actually, sorry, we don't use Mongoose here. It's another ORM to work with relational databases. So you can obviously use any database you want. And whenever there's a create action, I call a method that I wrote myself, which says update users. And all it does is to publish a message called update. And this will go to, again, to the ether, to the world, to the cloud, for whomever is listening. It may be listened by your backend services. It may be listened by your front-end services. This is a publish mechanism for updating the list of users. And yeah, this is basically how we do updates on the user side. All right, so there are not many interesting things here. It's all there is. It's just a single library. There are 4 different methods that you can use: send, publish, on, and no, there are only 3. So everything is happening out of these things. So there are no configuration. You can deploy these anywhere you want. And if you want to use Docker or Kubernetes or any other cloud mechanism, we basically have every configuration that you can ever ask for, from your local configuration on your own machines to any cloud deployment, Docker Cloud or Kubernetes. So you can just make use of them, take them as a template. And we have some documentation on Code's own website. So you are encouraged to check them, basically. And that is the end of my presentation today. Thank you for coming. Thanks. The slides are there. The demo is there. The links. We have a kind of an active code community on Slack. So you can join our Slack group. And that is my contact information. And now that we have maybe a couple of minutes more, I can take some questions, if you have any. Or maybe it was too clear. Or maybe you were too bored. Please.
How do you deal with relational data? For example, if you want to get all user products.
Yeah. So the idea is every service, the question is how do you deal with relational data? And because now that you break down every model into their own services, what happens when you want to make a join? And you do it on the back end. You don't do it over the database. So you may have another service that connects to the user and the purchase services, or one of them can actually connect to the other. So, for example, the purchase service can get the details of a user and then do whatever it wants to do with those details. The difference is it doesn't get it from direct to the database, but the user service. So the communication between the services will happen a lot. That's why they should be in a data center as close as possible, so that you minimize the delay, basically, because there's a lot of latency in using multiple requests over the network, because you're not directly doing a join on the database. And it's some of the compromises that we make. In order to achieve autonomy and isolation, all services run their own databases, and if you want to access a data model, you just ask that service. and that service, tells you whatever it wants to tell you. It may cache the responses, it may not. It may reject your request. So you have to be prepared for all these scenarios in your code, which is why microservices are really hard to achieve. And many teams basically just don't care about these things, and then their services just fail. But yeah, please answer the question. Yes. The question is, what about the multiple instances of the same service? Do they share the same database? And yes, of course. If you have 10 copies of the purchase service, they all connect to the same database, hopefully. Or you may want to scale it out as well, so that you have different shards and different replicas and availability zones for different databases. But in the end, it should be the same data model. So that they're interchangeable, so that you don't care about which kind of purchase service that you're running. If there's another kind of purchase service, then it's already another service on its own. So please.
Can you summarize what code is doing under the hood in a sentence or two?
Yes. It's very simple. It works much like your auto discovery devices at home. For example, your phone discovers your Apple TV, or your Mac discovers another Mac on the same network, right? You don't do anything for that. And it's achieved by IP broadcast, a mechanism implemented in routers. So there's a special IP address or a block of IP addresses in case of multicast that these services are using. Code is basically using the same thing. If your phone can discover another device on the same network, why shouldn't your microservices or why shouldn't your own application code be using the same technique? That's where we started from. And yeah, it just works. Any other questions? I guess we have a huge break after this. So if you want to discuss other stuff in private or in person, I'll be here for a couple of more hours and we can discuss. And again, thank you for coming today.